Hello. So this is question number 36 from IIT JAM 2022 paper. So what is saying that let m be a positive real number and let u v belongs to this R square space R2 and R be a continuous function satisfying this particular relation, and let f belongs to this R2 where f xy is equal to u xy and v xy for all xy belongs to this R2. So we have to find which of the following is true, is or not true. So first, let's see the option that we have to check with the options. The first one is f is injective. So if f is injective, you have to prove. So we can write this f of x1 y1 is equal to f of x2 y2. So we have to prove injective. So means it is mapping, okay, 1 to 1. So I have to check whether if this it is 1 to 1. Now, so we know that f of xy is given as u of xy and v of xy. So we can write this in the manner that u of x1 y1 comma v of x1 y1 again u of x2 y2 v of x2 y2, right? So now let us consider, so this is one of the equation, so we can consider here that so if we assume, so let this u of x plus y is equal to x plus y, right? So also this u of x plus y equal to x plus y is equal to v of x plus y, right? So if we consider this, so here this case, this equation will satisfy over here, except, so in our case this except for the x equal to minus y. When x equal to minus y, it will become 0. So we will put a mod over here. So u of xy is equal to mod of x plus mod of y. Now if we rewrite the equation in this way, so it will be mod of x1, okay, so it will be mod of x1 plus, so we can just do it in this way. So y x of 1 mod y1, for the v we can write mod of x1 plus mod of y1 equal to mod of x2 plus mod of y2 mod of x2 plus mod of y2. So we can write it in this way. So does this imply, so from here we can see that x plus y, x1 plus y1, this is, it will be is equivalent to x2 plus y2 in this here. Similarly for this x1 and y1 is x2 and y2. So does it imply this? So if we just consider each of the element, so does this imply that x1 this implies x2 or y1 implies y2? So does it so? So if we write it in this manner, this, then we know that implies is in this way again. It's the symbol x2, or y1 implies y2. This is not the case over here. It doesn't imply. You cannot say it correctly. That confirmly that is yes, x1 implies x2 or y1 implies y2. So this is not true for this case. So f1, this f is not injective or 1 to 1, as we say. So option A is false in this. From this observation you can see. So now we will check that whether we have two options, that whether if k is open, then fk the function is open, and if k is closed, in option C, say k is closed in the R2, then function k is also closed in R2. So how we will solve with this? So let's take two set and let f be the function and it is you are giving it as xy and uv. So our set, there is the two sets, set A and set B. These are, so here we have to prove that if k is closed, means if here it is k, so that will be fk. So this is the diagram you have to choose, that set A and set B. So we have to prove that this f is in T2 space. So what is this T2 space? It is in topology. So this states that for two distinct points, there exists neighborhood of each. We can just write in this way, this neighborhood of each which are disjoint. So this is the main thing, disjoint from each other, right? So that is the thing. So you have to prove this with the T2 space. Okay, so we can write this in this manner. So we know that for T2 space, so the condition over here is for the T2 space to be here, this if and only if f is closed in the set A cross B, right? So that is the condition. So we have to check with this. So the condition is if and only if f is closed in the set A cross B. So what is this A cross B? So this is a open circle, so we can write it over here as x comma u, x comma v, y comma u, y comma v, right? Now if we consider the set, this is k over here, it is given, you can see the k is given over here and the fk. Okay, so if we consider the set k, so we can write here in the manner, in case of an open circle, so this x of y, it is x square plus y square open circle less than r square. If it is less than equal to, so with this a closed circle, so in this case we are considering open circle. So for the set we have this x u, x v, y u and y v, so we can write it in this manner for the set k1 for this. So this is, we can write this is k1, K2, K3, K4, right? So we can make it in this way. So if we put the K1, it will be x comma u, x square plus u square less than r1 square. I'm taking K2, it is x comma v, right? X square plus v square less than r2 square, right? Similarly, K3 set, we can write y comma u, y square plus u square less than r3 square. Similarly for K4, yv, y square plus v square is r4. Less than r4 square, right? Now if we consider, if we choose this u equal to x and v equal to y, so if we choose, so let us see the condition whether it is satisfied. So we will take this condition, we will take, we will work with this. So x square plus y square is greater than equal to m over root over the x square by y square. So if we write in this manner, so it is, I think that we can consider this two things, that so here it is, the condition is given, so we can write the condition. So u equal to x, v equal to y, so we have u square plus v square greater than equal to m square of x square plus y square. So if we put the value of this, so it will be x square plus y square equal to this x square plus y square, where m is 1, right? So you can consider this u of u equal to x and v equal to y. So we can just rewrite this 4 sets as K1. So K1 will be x comma x, yes, x comma x, open interval, open circle. So K2 is x comma y, K3 y comma x, K4 y comma y, right? Now if we plot this in a graph, so suppose we have, right, so if we plot this x comma x, x comma y, and y comma y, y comma x and y comma y, so we will get this point like this. So it will be this x comma x, right? It will be sum of x comma y, it will be y comma x, it will be y comma y, right? This is the set. So if we put the value over there, So this is x squared plus x squared, so it is open circle, is equal to this less than r square. So if we draw this open circle outside in this manner, so this has an open circle, this also has open circle, this also has an open circle. So this has the radius of r1, right? This is r2, this is r3, this is r4 with this 4 radius. So now if we consider two elements in this particular, so this is for the k1, so suppose in this k1 this is k2, right? Okay, so we can also make it as in this manner, that suppose there is an element, this alpha 1 belongs to k1, subset of k1, and alpha 2 is k2. So if we do this k1 intersection k2, so k1 intersection of k2, it will be 5. Okay, so these are two disjoint from one another, so that's why it is coming, the intersection is 5. So from here we can make that A cross B belongs to this T2 space. So if A cross B is a T2 space, so this F is closed, right? So this function is closed function, this one. So from here you can see that K is closed, this F is closed means Fk is closed, right? K is also closed over here. If K is open, then Fk is also closed, right? So here the option C is correct, that K is closed in the R2, then Fk is closed in R2. Now let's check with the option D. So for that case we will have some so we can write it in this manner for the problem D, that's option D. So what it is given, suppose we have two set, right? This is xy and uv, and we know that F is closed, right? Now if we have a closed set that is given E, so E is a closed set, then the pre-image of E in this manner, here in this case, the pre-image of this will be compact, that is closed and bounded. You have to prove this, right? So we know that, so it will be just in this case we'll find that we know that this U and V, these are continuous function, right? These are continuous functions. So U, we can write it as U V, this is a belongs to this R2, is a continuous function in the space R, right? Now inverse of a closed set is closed. So what is the saying? This, we know that inverse of a closed set, so I've already proved these are closed, so this E is a closed set. Inverse of a closed set is closed under continuous function. So you have to find the pre-image of this closed set E. So which must be a compact set. So compact set means closed and bounded, right? So from here we can write this. So the compact set, we can write the pre-image. So this compact set, suppose this compact set, the pre-image under continuous function, okay, it will be itself a compact set that is closed and bounded. Okay. So this under so it will be 2a. The pre-image will also be a compact set. So option D in our case is true. So this set of a closed set, inverse of a closed set, is closed under the continuous function. So from here we can write that U of U inverse E is closed as V inverse E, both. So the options, you can see from the option D what is saying that if E is closed and bounded in R2, then the pre-image of that closed set is also compact in R2. So D is correct option. So there are two correct options. One is C and D. Okay, for this question number 36.